All right, so first up, I want to define polygon for you. That you've heard this word before, but just to make sure everybody's on the same page, a polygon is a closed figure formed by three or more line segments called sides. Okay, and again, like I said, you know that. All right, so we're going to fill in this chart. Okay, and it's going to deal with the whole triangle concept that we talked about in the last video. We're going to see if we can find a pattern or like some formula that we can use so that we don't have to draw out a picture and count all these triangles every single time that we're trying to find the sum of an interior, the interior angles of any sort of polygon. Okay, so triangles obviously have three sides. Okay, quadrilaterals obviously have four sides. Pentagons have five, hexagons have six, heptagons have seven, octagons have eight, nonagons have nine, and decagons have 10. We can go on further, okay, like an 11-sided figure does have a name, a 12-sided figure does have a name, but we're not going to worry about anything past this, okay? So these are the ones I'm going to have you like either memorize or write down. Just these are the ones you're going to have to remember, okay? So now the next column is, well, how many triangles can we make with each shape just by like drawing lines through them, okay? Well, the triangle, obviously we can only have one triangle. With a quadrilateral, we draw that one diagonal and we get two triangles. With a quadrilateral, or a pentagon, sorry, we've got two triangles, with a pentagon, we have three triangles we can make. Hexagon, obviously you might see a pattern going on. We're just increasing the number of triangles we have by one every single time, okay? And now if we take all of those triangles and add in their 180 degrees, okay, so this first triangle only has 180 because there's only one triangle. The quadrilateral has two, so it's got 360. Pentagon has three, so it's got 540. The hexagon has six, so it's got 720. And then we've got 900, and then 1080. And then, let me double check my math, 1080 plus 180 gives me 1260. And then add one more 180, and we have 1440. Okay. And you're more than welcome to memorize all this, but that's a lot of stuff to remember. Okay, it'd be much nicer if we had a formula that we could just plug in every single time we're trying to answer this question. That's what this next piece is. Okay, so we're going to let a variable n represent the number of sides in a polygon. So here we have triangles got three, that'd be our n. Quadrilaterals got four, that would be our n. Okay. Then the sum of the interior angles, which we usually label S, can be found using this formula. So let's look at this. It starts off with n minus 2. Okay, where do you think I'm getting what this n minus 2? Where's that coming from? What do you think that is supposed to be representing in this formula? Well, n minus 2 is just giving us the number of triangles that are in the shape. Okay, so n minus 2, we take the number of sides, subtract 2, and this number here is the number of triangles that can be made in that figure. Okay, and then all we have to do to find the actual sum is take the number of triangles, and we know each one of those has 180 degrees in it. So we multiply our number of triangles times 180 degrees, and we get our sum. So I'm going to write the sum of interior angles. And this will work regardless of how many sides, because look down here. Okay, first couple examples. Like I said, every shape does have a specific like actual name, but once we get past 10, we're not really that concerned about it. Okay, so you're going to see it mostly when I go past 10, you're going to see something like this where it says 15 gone, and all that means is it's a 15-sided polygon. Okay, so our n in this case is 15. Okay, so if I plug my n into the formula here, I'd have 15 minus 2 times 180. Okay, which is going to be 13 times 180. A 15 gon has a sum of 2,340 degrees. Don't forget your degrees. Okay, let's try one more. All right, we got 21. 21 minus 2 is 19, or I'll write this whole thing out for you. 21 minus 2 times 180 gives me 19 times 180. A 21 gon adds up to 3,420 degrees. Okay, and then let's see, the next two, 46 times 180 gives me 8,280 degrees, and then 36 minus 2 times 180 gives me 6,120 degrees. All right. Okay, so that's the first type of problem. Let's look at the next type. Okay, so now we have to throw in this like extra like wrench, okay, and that is this idea of a thing called a regular polygon. So let me give you a couple examples of regular polygons we've worked with so far, or you may have worked with in the past. This year we've definitely worked with an equilateral triangle. That is a regular triangle. You've also in the past worked with squares, and squares are regular quadrilaterals, regular four-sided figures, okay? So think of what you might think the definition might be if equilateral and squares are both regular polygons. Well, they are just a polygon where all the sides and angles are congruent. Okay, so every side's the same, every angle's the same. Okay, so we can adjust our formula a bit and ask different questions. Okay, so these questions are saying, it says to find the measure of each interior angle of a following polygon. So I want to know each individual angle. I don't want all of them together, but I want one individual one. So if I took like a triangle, equilateral, okay, it's called equiangular and equilateral. It's a regular triangle. That means all the angles inside are the same. We've seen something like this before. We know all the angles add up to 180, but I just want to know what the measure of one of them is. So I divide it by the three angles, and I would get 60 degrees, okay? So this, okay, remember this part right here we got from that n minus 2 times 180, okay? But then, where do you think this divided by 3 came from? Well, there were three angles, right? Or there's also three sides, okay? So right here, we can also divide by the number of sides, and that will give us the individual angle in a regular polygon. Okay, so this is a new formula, okay? So here we want to find each individual measure of a regular pentagon. Well, a pentagon has 5 sides. So if I want to find the measure of one of those angles in that pentagon, we're going to do 5 minus 2 times 180, and then divide by 5. Bring my calculator out. Let's see, 5 minus 2 is 3 times 180, and then divide that by 5. We get 108. So just to be clear, so the 540 is the pentagon as a whole. Every angle inside the pentagon has to add up to 540, okay? And then we divide it by the 5 individual angles, and we get 108 for each angle in a regular pentagon, okay? Then the same thing's gonna happen over here for this 18 gon, okay? So we're gonna have 18, try that again, 18 minus 2 times 180 divided by our number of sides. So we're gonna get 16 times 180 divided by 18, and we're gonna get 160 degrees for each individual angle in that 18 gon. Okay, so that's gonna be it for this first video. The next video is gonna talk about exteriors, and then we're gonna talk some examples.